So I'm going to I'm going to give a talk on basically the constellations and what they are. The Jersey Astronomical Association. There's a picture of our observatory. It's in Voorhees State Park in Highbridge, New Jersey. It was founded in 1965 by a group of 7 friends who were basically a telescope making club. And then one day, one of them said, why are we all making telescopes? Why don't we pool our resources and have an outreach for the public? So they approached Voorhees State Park and they said, this is what we'd like to do. We'd like to have an outreach, but we need a place to put our observatory. So they said, well, here's this hilltop in the park and you can put your observatory there. And they charge us $1 a year. And that was in 1965, which of course was a lot of money in those days, but it's not so much nowadays, but that's still all they charge us. The buildings are ours, but the grounds are theirs, and it's in the park. So we rely entirely on donations and members' dues to fund the operations, but we do, in honoring our agreement, provide public open houses on Saturday evenings and Sunday afternoons, free of charge. We offer weekly tours of the sky, instructions on how to operate your telescope. If you come by, people, they're very enthusiastic about this subject and they're willing to help anybody who is interested in any way, answer questions and refer you to people who know how to do that. We've also have the largest telescope in New Jersey that is accessible to the public. Of course, you need supervision. We have qualified observers for that. We also have youth programs. And member benefits include loaner telescopes. You can check them out just like a library. And we have special astronomy classes. And we have groups that are special interest groups like astrophotography and research. We are a registered working observatory with the International Astronomical Union, Minor Planets Group, and or actually it's Minor Planets Center is what they call it. And we provide data to professionals that are doing research. Okay, so what are constellations? If you ask NASA, they'll give you these definitions. Basically, there's a word for a pattern in the sky, which appears to be so distinctive that it is easily identifiable and remembered. And that word is asterism. So in ancient times, people saw these asterisms and made up all kinds of stories and mythology about them. And in different parts of the world, everyone have their own, mythologies and traditions. And they have their own asterisms, a lot of times with the same stars. China has a whole bunch of constellations that are different than European constellations. But the AIU pretty much works with the European tradition. Similarly, there are folks in the Southern Hemisphere who traditionally have their own stars, which weren't even known to the Europeans. Anyway, astronomers subsequently began to make maps of the stars. And the named asterisms were included in the maps, and they were called constellations. So an example of an asterism is, this isn't very bright, but if you let your eyes get used to it, I guess. Here's the Big Dipper. And so you can see it's 7 stars, and it's in the sky. These are boundaries, these sort of brownish lines. Here's the Little Dipper, another asterism. And the Big Dipper is part of a larger constellation, which is called Ursa Major. The Little Dipper is in Ursa Minor. You can see the pointers here point to the North Star. The thing about the North Star is that it is so close to the celestial pole, which is the celestial North Pole, that it never appears to move. It just sort of goes in a really tight little circle around the North Pole, which makes it very handy if you need to orient yourself at night. It always will be in the north, and only about a ½ degree from true north. So here's the Big Dipper again in its constellation Ursa Major. You can see that it looks kind of like a sort of a peculiar long-tailed bear. It has paws and feet, legs. It has a nose on this end, and the Big Dipper is pretty much his hindquarters and tail. Note also that the constellation has boundaries, and those boundaries abut right up against the adjacent constellations. So there's really no open space. Every part of the celestial sphere is within some constellation. Also notice that the stars have names. They have their classical names, but as more and more stars became known, it became convenient to just give them a designation. So here you have basically Greek letters, which was started at the very beginning of the 17th century by Johann Bayer, and we'll talk about him in a minute. Other asterisms are seen in the classical constellations. Here's Centaurus. There's Alpha Centauri right there. Centaurus looked kind of like a man, had a sort of a head and a torso and arms that went off to the sides, and it was all set on top of what appeared to be a quadrupedal organism here, like a horse. And so they called it Centaurus, because it reminded them of the mythological centaur. Lupus is a little bit harder to figure out. Lupus means wolf, but someone saw wolf there. Scorpius, you can see, looks like a scorpion. It has a sort of a long body. There are claws which actually go over into this other constellation, Libra, but the stars retain the names. This star, Alpha Librae, is Zubin el-Janubi, the southern claw. It's Arabic. The northern claw is Zubin el-Shamali. So here's an asterism that actually spilled over into two constellations, Libra and Aquarius. Sagittarius is here, the Archer, but the asterism that one can see, there can be multiple asterisms in these constellations, looks like a teapot. And all the bright stars of Sagittarius actually look like a teapot. And you can actually see this in the early fall, a few hours after sunset, right along the just above the southern horizon, if you have a pretty clear shot at the horizon. Anyway, and Aquila here looks like an eagle. There's the wings and the tail and the eye, and the head is up here. Ophiuchus looks like a man. Serpens looks like a long, narrow thing, so it's a snake. Ophiuchus means serpent handler. And Triangulum Australe, which means southern triangle, looks like a triangle. So if you go to the Naval Observatory, they have a glossary of terms. And if you look up constellation there, they call it a grouping of stars, usually with pictorial or mythical associations that serves to identify an area of the celestial sphere. A more modern definition is one of the precisely defined areas of the celestial sphere, there's 88 of them, associated with a grouping of stars that the International Astronomical Union has designated as a constellation. So here's the constellations that are sort of near the North Pole. Again, there's Polaris, the North Star, but around it, and here's Ursa Minor, and around it there are several other constellations. There's Cepheus and Cassiopeia. Cassiopeia looks kind of like a W in the sky when the label isn't partly blocking it, but it goes something like that. And you can usually identify it as a W in the sky. Cepheus is the king of Colchis, and Cassiopeia is his queen. Andromeda out here is their daughter. Perseus is a hero who rescues Andromeda from a sea serpent, who's actually over in this area. Taurus is a bull, one of the zodiac constellations. Auriga, with the bright star Capella, so like the fourth brightest star in the sky, is nearby. Gemini with Castor, which is this one, and Pollux, first magnitude stars, are over here. Cancer also in the zodiac, so you can see the zodiac kind of follows around like that. Canis Venatici, the hunting dogs, which was a space filler. It wasn't one of the traditional original constellations. Boötes, which was a bear herder because of its proximity to the bears. Corona Borealis, which looks like a crown, has the bright star Gemma in it. Hercules, the hero, is right here. He's kind of upside down most of the time. His knees are pointing north. Draco, the dragon, which is right between the two bears. Cygnus, the swan, including an asterism, which is the Northern Cross. I don't know if you can see it here, but Deneb, the first magnitude star, is the head of the cross, and then going down to the tail, Alberio, and then across like so. The Chinese refer to this as the bridge because the Milky Way runs through here, and there is a bridge that goes across here. And they number the stars. That's just 1, 2, 3 of the bridge. Sagitta, a new constellation, relatively new, early 17th century. Vulpecula, named about the same time, both by Hevelius, probably the most famous astronomer and the latest who didn't use a telescope. Delphinus, Lucerta, another one by Hevelius, and Triangulum. So if we go off, this is where the constellations would appear in the fall. So you have the Big Dipper as low in the sky as it gets. So what that does is it gives us some room in this direction. So if we go off to the right, we see the stars that are in the winter. So as we come down, there was Gemini, which we saw before. Here's Orion, looks like a man in the sky. He's a hunter. There's Taurus, the bull. There's the Hyades, a much studied cluster about 153 light years away. There's the first magnitude star Aldebaran, which follows the Pleiades to the sky. Here's the Pleiades, another cluster. 7 sisters in Greek mythology, daughters of Atlas and Pleione. The Hyades were also sisters. Actually, they were related to the Pleiades. Their name brings water, or water bringers, because when Taurus is high in the sky, it's winter is coming, and that's when the rainy season was in the Mediterranean region. Below Orion, you have Lepus, the hare, kind of looks like a bunny, sort of. Canis Major with Sirius, the brightest star in the sky. It's like a dog that follows Orion. Monoceros was a space filler added by Planetesimals. Canis Major, one of the classic, minor, one of the classic constellations, was pretty much along, usually considered along with Canis Major to be one of Orion's dogs. Hydra was one of the creatures that was one of the labors of Hercules was to destroy the Hydra, which was ravaging the site. It had multi heads. You kill one and 2 would grow back. Columba was a space filler, a recent one. Fornax also. It means a laboratory furnace. It was named by Lacaille, who named a lot of constellations, and most of them were named after laboratory equipment of one kind or another. And also Eridanus, the great river of the sky. It's the longest constellation. It just goes and goes. It was long and narrow. Anyway, on Aries, another zodiac constellation. You'll notice also that the ecliptic runs here, and that is the plane that all the Earth and Moon, the Sun, and the planets all are in. And notice that the zodiac constellations, Cancer, Gemini, Taurus, Aries, and all the other ones pass through the ecliptic. It's called that because you can have eclipses in it. The Earth, the Moon, the Sun are all in that. Okay, going south from there, excuse me. So, in other words, moving this direction, when the age of exploration came up, you can see that you have the southernmost parts of the classical constellations, but the people in the south didn't. They had different constellations or different uses for the stars, but this was the age of exploration when they moved down there, when Europeans settled this area, or actually explored this area. And the Dutch East India Company sent out a ship to go to the East Indies. It went around the Horn of South Africa, and two surveyors, or celestial surveyors, navigators, were on that ship. Peter Kaiser and Frederick de Hooten, if that's pronounced correctly. And they cataloged a lot of these with the help of Plancius, who basically was this astronomer who coordinated with them. But they named things after what they saw. So there was Indus, which was named after the people of the East Indies. But they also saw, that's this one right here, there were birds. In addition to the phoenix, which is a mythological bird, there was grus, which is the Latin word for crane, tucana, which was a toucan, dorado, which literally means golden one, but it actually is a kind of dolphin fish. Volans, which was a flying fish. It was actually piscis volans, flying fish. Volans is flying in Latin. Musca, which was a fly, I think mosquito probably. And I think that's, pavo, which was a peacock. And apis, which means no feet, because it's a bird of paradise. And when they first saw the birds of paradise, they were not able to see their feet. Eventually, somebody caught one and they dissected it, I guess, and found the feet. Also in the south are the southernmost of the classical constellations. There's Ara, and all of these other ones we've named. Crux was cut out of Centaurus by Plancius around the Southern Cross, and you can see the Southern Cross right there. Crux means cross in Latin. Also, there was a former constellation that these three constellations were, and that was Argo, the ship that carried the Argonauts. Lacaille, who again was famous for his work in South Africa. In 1763, he published a catalog, and again, he was very interested in laboratory equipment. So horologium is a clock, reticulum is a measuring grid. Mensa was named after Table Mountain, which is in outside of Cape Town, South Africa. Circinus was a compass that is used by draftsmen, so it's a drafting compass. Norma was a ruler, or actually a right angle, like a right square, a carpenter's square. Telescopium is pretty obvious. Microscopium also. And there were pictor, which was an easel. And there's a sculptor, which is a sculptor's studio. So those are all named by Lacaille, and they're all space filters. Notice that all the constellations in the south are pretty small relative to a lot of the classic constellations, some of which are very large. And the reason was because they were now interested in science for scientific reasons. They were interested in determining where stars were and having more precision. So they had smaller, more constellations. And that's the reason that they had more constellations added as fillers up north as well. So continuing on, the constellations of the summer, we have Scorpius, which was mentioned earlier, Libra, Sagittarius, there's the teapot there. Serpens was divided into, well, this long, narrow thing, but since they were not allowed to have more than one star in more than one constellation per star. Some of the stars in the middle were assigned to Ophiuchus, which is the serpent handler among the classical. So Serpens actually has two separate locations in the sky, one for the head, caput, which is Latin for head, and cauda, which is Latin for tail. There's Aquila, Sagitta, which we've already could see in the northern constellations. And so we'll go to the next. Okay. So this brings us up to the north again. This is the same we had before, but if we rotate the things, notice Ursa Major is here. If we rotate it around to here, it's basically advancing at 6 hours. Now on this long plane, we can look at the fall and winter constellations. So again, Andromeda, Pisces, and Pegasus. Okay, we'll head off in that direction. Okay, so here's Pegasus going down in that direction. Here's Pegasus. Pegasus has 4 stars which make up the great square of Pegasus. Also, one of the stars is the head of Andromeda. So that's this one right here. Even though the name Alpheratz means the belly button of the, or the navel of the horse. So Pegasus is this large horse. Here's his nose over here. Aquarius was a space filler. I'm sorry, no, it wasn't. It was a classical constellation, but it is called Aquarius, which means the little horse, because Pegasus was the big horse. There's Delphinus. There is a group of stars here which make a kind of a tight thing. It's referred to as the asterism Job's coffin. So Aquarius is here. Capricornus. So these are the fall constellations. Cetus, which was the sea monster that Perseus had to kill, is down here. Pisces Astrina, the southern fish with the bright star Fomalo right here, means the mouth of the fish, Fom al-Hut in Arabic. And there's Sculptor and Fornax, which were fillers by Lacaille. Oh, and there's also Aries, the zodiac. Notice that the ecliptic runs through this way. So you have Aries, Pisces, Aquarius, Capricorn. Okay, and then going down to the south again, well, we've already seen pretty much all of these, but continuing, there's Sculptor, Phoenix, Toucan. And then if we go off this way, we can get to the constellations of the spring. There's Crux, the Northern Cross, I'm sorry, the Southern Cross. If we go here, then there's a good view of Hydra. And Sextans was a filler constellation made by Hevelius. So was Leo Minor. Cancer, Leo, Virgo, and Libra complete the zodiac. Leo has the bright star, first magnitude Regulus here, also a second magnitude Denebula. Virgo has the bright star Spica. And Arcturus has the bright star, this is the third brightest star in the sky, Arcturus. Okay. Arcturus, Virgo, and Nebula make up pretty close to an equilateral triangle. There's some distortion in this view, but it's called the spring triangle. And Corvus has 2 pointers, one of which is hidden behind the label here, which point to Spica. But that's a pretty easy sort of see in the springtime, low in the horizon if you have a view in that direction. And there's Crater too, which is like a cup. So it's sort of like that. Anyway. So that brings us back up to the north, following in this direction, Coma Berenices, the hair of Bernice, Queen of Egypt, has an interesting story about how the royal astronomers stepped in and saved the priests of Aphrodite from certain death by quick thinking. So there's an interesting story, and there's some links that I provided you here if you want to hear about that, or the story of any of these constellations. You can go to those links. Canis Venatici is, and Leo Minor were space fillers and also links by Hevelius. All right, here's those links I was talking about. Ian Ridpath's, just very comprehensive, great writer, great stories. Jim Kaler, he's a professor emeritus at University of Illinois, and he's also a very good writer, and he writes a Star of the Week column. It's SOW. So that's the link for that. And there's a section on constellations in there. Very good, very comprehensive. This constellation guide has some interesting things in it. If you want to look a little bit more into constellations and what's in them, this is a good place to look. And then there's also Constellation Legends by Norma Carter of Tulare County Education Department. And there's a section on constellations. This is a relatively new one. I haven't looked at it very much, but it looks like it's got some stuff in it that some of these other ones do not. Okay. Now, I'm not sure how much more I have, but I'd like to go into the history of constellations and why we have them. And I'll try to go through this pretty quickly because I've already mentioned a lot of these things in here. But, you know, where do the constellations actually come from? You know, we're trying to ask what are they, but where did they come from? And I think we even have them in cave paintings. Here's the IAU map of the part of the sky that has Taurus in it. Okay, and Taurus is seen, again, here's Aldebaran and the Hyades. There's the face of the bull. Aldebaran is one of his eyes. And then here's the Pleiades over here, nearby in the sky, but several hundred light years away, whereas the Hyades are only about 165, or so 150, I think. And Aldebaran's about 65 light years away. So it's much closer than the Hyades are. It just happens to be superimposed on them. And the horns, it's a long hair. It's like an aurochs, like a European wild cow. They're extinct now. I think they've been trying to reconstruct them, but the horns go to these points, El Nath, which is shared with Auriga, and then there's also Zeta Tauri. So they go, by the way, the Crab Nebula is right next to this thing. Anyhow, so you see there's this bull with a face and long horns and the Pleiades on its back. So here we have in a cave in a place called Lascaux, which is in southwestern France. These are cave paintings. This cave has the basically organic materials there have been carbon dated at 17,000 years old. So that means that these cave paintings are 17,000 years ago. So 15,000 BC, thereabouts. And what we have here is a picture of a long-horned aurochs, a European wild cow. And we have on its face, its eye, and then some dots, which are kind of weird because they don't appear on any of the other cows, any other bulls. This is the hall of the bulls. There's lots of bulls in this painting and paintings on the wall. Behind its back, you have this row of 4 stars and then, or 4 dots anyway, and then 4 dots below it. So anyway, here's the Pleiades. So there's 4 stars that can be seen. The Pleiades are a test of eyesight. If you can see this star, Seleno, you're considered to have excellent vision. Most people can only see 6. People like me can see maybe only 2 or 3 of them. But you can see 4 stars kind of in a row: Atlas, Maya, Electra, and Teegida. And over here, the 2 stars, Merope and Electra. So 17,000 years ago, astronomers have said, since this is a cluster, these stars do move slightly. So it's possible that 17,000 years ago, they were in a pattern that was maybe a little bit tighter, a little closer to this. It wouldn't have been any brighter, so the star that was the stars that are dimmer may not have been easily visible. So here they are, and here are these other dots. If they are stars, they can look like they correspond pretty well, position-wise and proportion-wise, to the horns, the face, and the Pleiades on the back of the bull. And if this is true, that means that we have had what appears to be a bull in that part of the sky, or what people recognize as a bull in that part of the sky, for 17,000 years, which makes, to a certain extent, these constellations potentially one of our oldest traditions, the oldest traditions of humankind. Here's another picture of the cave. Shows that it's up in the sky, and very often it does appear this way because when it's off in the west, it's setting, and so these stars are going down towards the horizon. These are stars that are further east, so they're higher up. At that time of the year, it would have been the late winter, and perhaps a signal that spring was coming. There are other ones that are known in antiquity, though not quite as old. Here's Hydra again, and there's Leo. So you see Leo pretty much on the back of Hydra. Again, these were, at least this constellation, Sextans was a filler. So anyway, if you look at in 3000 BC, we had late Babylonian representation of Leo and Hydra. And these do have the names, these are star constellation. Notice the prefix sort of indicates that this is a star field. This is cuneiform, but there's Hydra, there's Leo. This could, some people looked at this and said, well, off in that direction is Sirius or maybe Procyon, which are very bright stars. But according to this label right here, that's actually the planet Jupiter. But still 3,000 years ago. So there were a lot of stars in antiquity. And here's Ptolemaeus. And all those stars that I called traditional constellations were gathered up by Ptolemaeus. And in his work, the Almagest, contains 48 constellations. And as you know, currently today we have 88. So the rest were fillers or those southern constellations. And you can see them on this. They're kind of color-coded as to when they were first introduced and what group they're in. They sort of group them for just organizational purposes. This is fairly recent grouping. In fact, this is from IAU, and presumably it's their grouping. So it's 21st century or late 20th century grouping of them. But you have the fillers are anything that are not black typeface. And so you can see that there. And the handout that I had, I don't know, Mr. Tukey, whether or not people were able to get that. Did you get my handout? The handouts, the PDFs?
We haven't distributed it yet.
But anyway, you said something about a website. But anyway, that there's a pronunciation guide, and the pronunciation guide has the names of the constellations, how they're pronounced, at least according to the English pronunciation, the genitives of those, because that's how the stars to them are assigned to them. So it's the star, the Alpha of Centaurus, so Alpha Centauri, and also basically who established them or whether they were ancient, and so forth. Here you have the zodiac following the ecliptic, and then you have the ones around each of these various groups. And the typeface tells you what catalog they basically came out in. But the pronunciation guide will actually, I've actually put in that who is responsible for erecting that constellation. And this figure basically shows how the ecliptic works. You have the Earth and the Sun, and it follows a certain path. And then, so looking from the Earth towards the Sun, astronomers or astrologers actually were able to determine that the Sun went through various of the zodiac constellations at various times of the year. Now, the Earth is tilted relative to its plane of rotation, which is why we have seasons on the Earth. But that means that the North Pole and the South Pole are, just as the North Star never moves, the celestial pole is always in the same spot, and the celestial sphere is always at the same latitude, or is overhead at the same latitudes at least once every sidereal day when it passes overhead. But we know that through time, the Earth's axis actually goes through what they call precession. So it moves kind of like a top when it's spinning. Its axis stays fairly constant, but it rotates. And in the case of the Earth, it rotates about once every 26,000 years. So currently, even though the celestial equator, the celestial equator and the ecliptic cross at the equinoxes, the spring, the vernal equinox and the autumnal equinox, that isn't a constant thing. So 1,000 years ago, the vernal equinox was in a different constellation than it currently is right now. So it was in Aries instead of Pisces. Anyway, that moves. And so as a result, what's the North Star changes. And so it'll be back here again in 26,000 years, but on its way there, it'll go through a bunch of other constellations than the Ursa Minor. Okay, so quickly, here's some of the people who came up with the modern ones. Here's Coma Berenices, who's by Kaspar Vopel in his catalog. Actually, it was a globe. And there's a picture of Queen Bernice, and that's her hair. And like I said, you need to read the story, but you can look at Jim Kaler's or Ian Ridpath's descriptions of what happened to her hair and what the whole story was behind that, and how they saved the priests of Aphrodite. This is Pelancius. He collaborated with a bunch of constellations, but these ones he named on his own. Monoceros, a space filler. Columba, which was a space filler south of Lepus, which is south of Orion. Monoceros, which was a space filler between Orion, Canis Minor, and Canis Major. And as I mentioned before, Crux, which was cut out of Centaurus to give the asterism the Southern Cross as its own constellation. Okay, these were the explorers I mentioned earlier, Kaiser and de Houtman. And here's a picture of their constellations with the images of what they thought. Here's the bird of paradise, the peacock, the toucan, the crane, the water snake, the dolphin fish, the flying fish. And this one also has some constellations that didn't survive, that weren't named by them, but this is not an atlas from their time, but from the early 19th century. Then you have Hevelius, which I mentioned. Excellent observer, master astronomer. He was an excellent craftsman. He actually made this quadrant for a friend of his. And look at the detail that's on that thing. Here he is with the sextant in a painting that was done of him. This is his wife, Elspeth Koopman, or Elizabeth. She was much younger than him. She was his second wife, much younger. You notice that she is the one who's looking down the eyesight here, looking at the constellation. What he's doing is measuring the reticule on the bottom. Like I said, he's much older. His eyes are able to look at that at arm's length anyway. Notice it's very, very large, because he found that the larger the sextant, the more accurate its readings. When he died, there was a tragic fire, and his observatory was destroyed. He died about a year later. She worked with him. She knew all his work. She did many of the descriptions by herself, and he just measured them. She took his notes, well, actually their notes, and she published them. And she was greatly admired by Isaac Newton and by Edmund Halley. And she actually got what do they call it? Basically an allowance from a patron. So she is probably the first paid woman astronomer. Anyway, she also had 4 children and did a bunch of other neat things. And she has a biography as well. Hevelius's atlas, this is what she published. It was to his patron, the most serene, the most powerful, and the most unconquered, John III, King of Poland. At least that's what it says in Latin right here. It was a big thing to name stuff after your patron. And if you could get a constellation named after him, this one right here, Scutum, it's not called Scutum. Then it was called Scutum Sobieski, Sobiescanum, I guess, because it was John III Sobieski. So he sort of sneaked this one in as a, well, in honor of his patron. Some of those, though, and Antinous, for instance, which was part of Aquila, even though it made it into his atlas, was subsequently removed because it just started to get a little crowded there. So here's the northern half. See the Great Bears, etc. There's a sextant there. Looks like a couple little angels taking a measurement. This is an octant. But you can see how crowded it's getting. Hevelius named a bunch of constellations. Here's all the greats of astronomy. This is the Muse Urania, the muse of the sky. Here's the Scutum, the shield. There's the sextant. And here's all those other ones, the hunting dogs, Canis Venatici, Lynx, Leo Minor, Vulpecula, and this little thing that looks like a rat is probably Lacerta. I guess they didn't have too many lizards in Poland in those days. Okay, then came Johann Bayer, and he showed his constellations as we would see them from the Earth. Prior to that, I don't know if you noticed, the constellations were reversed because it was considered to be the outside of a sphere. And so just like the Earth's surface, the sky also had a surface that was viewed from the outside, sort of God's view of the sky. But Bayer was interested in presenting them in a way that astronomers could use them. So in his Uranometria, he actually had them looking at him at the sky. So you have Orion looking just like Orion here. Here's his cloak or bow, some people call that. His Betelgeuse, Rigel, his belt, etc., Safe, Bellatrix, just as they would appear in the sky. And he invented a system to designate the letters using the Latin genitive. Like I said, your handout has those, or it's three-letter abbreviation, and then letters of the alphabet. He started with the Greek letters. I started with the brightest stars. So the first magnitude stars got named first, so alpha, beta, etc. Alpha is usually the brightest star in the constellation, though not always. And then the second magnitude, so forth and so on, and until you ran out of Greek letters. And the order of assignment was kind of arbitrary, even though it looked like sometimes it was according to brightness, other times in order of rising. But other than that, pretty much arbitrary. So here is Lyra, the lyre. It's a northern constellation. Alpha star is actually the star Vega, a bright first magnitude star, probably the fifth brightest star in the sky. And then you have Chiliac and Sulfat. Sulfat is actually brighter than Chiliac, even though it's the gamma star, but Chiliac rises earlier. Then we have Delta, Epsilon, and Zeta, which is the next letter in the Greek alphabet after Epsilon. And notice that Epsilon has a 1 and a 2 because there's a little double star there, and Delta also has a 1 and a 2 because it's a double star. So when you use up the Greek alphabet, they went to Roman letters, first the lowercase, then followed by the uppercase, with letters R through Z reserved for variable stars. And this is more modern. And then when you got to Z, then you would go to RR through ZZ, and then AA to QZ. And then once you, after you finished all of those, then they went to just V followed by a number, which is probably a good way to do it. Again, the double stars, according to Bayer, he would just give them one letter of the alphabet and then just call them with a superscript 1 or 2. And also he had a tendency to do this with chains too. So Orion's bow, it looks like this, is pi 1 through 6. You can see it here. And there's also some doubles in Orion too. And then originally stars, it got to be the point where there's getting to be so many stars that, so many constellations that some stars would do double work. So they would be part of two constellations, like El Nath, which is one of the horns of Taurus, and also part of Aurigae, and also Alpheratz, the navel of the horse, which is also the head of Andromeda, but it was also known as Delta Pegasi. That's no longer allowed, so they had to get rid of that. But so if you look at this one, here's Andromeda. You can see that Pegasus, which is over here, is now shown without the great, even though the great square is still there, the constellation doesn't include it because it's the Delta, because it's now only considered Alpha Andromeda. All right, and then finally, after they defined the boundaries for the constellations, some stars were no longer in their normal constellation, so they had to be named. So Alpha and Beta Normae, for instance, is now N and H Scorpii. So as things got more complicated, more stars were being known, it became less and less convenient to try to assign randomly, almost randomly or arbitrarily, a Greek letter or a letter of the alphabet to the stars. So John Flamsteed, who was a royal astronomer, just before Edmund Halley, had the neat idea of just saying, well, let's just put them in the constellation. We'll keep Bayer's Latin genitives for the name of the constellation, but will just number them in order of their rising. So according to right ascension, basically, the stars are numbered. So 7, and then you have 8, 9 are probably out of the field of view, but you have 11, 12, 13, 14, 15, 16, 17, 18. 19 is probably out of the field of view, 20, 21. So you can see that the numbers increase as you go in this direction, which is towards the west. So anyway, that was considered to be a really neat idea. And even though Flamsteed they're referred to as Flamsteed numbers now, even though Flamsteed never really approved it for publication, it didn't appear until the final edition, Newton and Halley really liked the system and included it in preliminary editions, and they didn't get Flamsteed's permission. That could have been a problem nowadays. Many other people liked it as well, and so it's used for dimmer stars where Bayer hadn't assigned a designation. Also, Flamsteed actually observed Uranus back in 1690, but didn't know he was looking at a planet. So he called it, it happened to be in the constellation Taurus at the time, so he called it 34 Tauri. But, and it wasn't until much later that William Herschel noticed that it was moving. And he called it a comet, but other people who saw it, looking at it as a comet, realized that it wasn't a comet. And they finally convinced him that he discovered a planet, which he then acknowledged. Okay, so also in some cases, when the constellation boundaries changed, these ones didn't change. So 10 Ursa Majoris is actually in Lynx, just across the border. And then there's Lacaille, who, as I said, had a lot of the fillers in the southern hemisphere, and named most of those ones that are some kind of laboratory equipment or Table Mountain or something like that, compasses and so forth. Anyway, with the success of a lot of things that were going on here, constellations being named, new ones being introduced, they're kind of, and there's still a certain amount of pressure to make things more precise in the sky. You have other people naming constellations, and it's really starting to get a bit much, but John Bode's Uranographia did something that no one had done before. And you can see these little, very thin lines, and these are boundaries. See Rangifer here, the reindeer, and a no longer existing, and Felis, the cat, no longer a constellation, had boundaries around them. So here he is attempting to show boundaries, and this was considered to be, the last big step, was to put actual boundaries around the constellation so that something could be in or out, but not in any place between. So you could be in one constellation or in another constellation, and there was no part of the celestial sphere that wasn't part of a constellation. So here's some detail from Bode's Uranographia. He had about 100 constellations and then these 6 sub-constellations, one of which would be the head of Medusa, which is what Perseus used to turn the sea monster into stone and saved Andromeda. But there's other ones like Musca Borealis here, and some other ones, Custis, Messium, which are no longer considered, but were part of these old atlases. And again, you can see the boundaries around the constellations. So anyway, enough was enough. Once the IAU got started, they said, okay, we need to rein this in a little bit. So they said, okay, there's only going to be 88 constellations. I guess, I'm not sure how they got 88. Maybe they had a piano or something, I'm not sure. But 10 or 20 others needed to be relegated to asterisms or to the scrap heap of history. The boundaries of surviving constellations were expanded to fill the celestial sphere, to basically to take the place of the ones that were removed. And AIU had no requirement for easy visibility because people were using telescopes nowadays, so they didn't really need to have that. They just needed to know where. So IAU's plan was to get Henry Norris Russell, and he was selected to, basically he was probably the most prestigious astronomer of the earliest 20th century, earliest part of the 20th century. So they figured if they put Russell's weight behind it, it would go, and it did. It worked. People were willing to do that. Anyway, as far as the ancient names were concerned, where possible, they were to be retained. They got a celestial surveyor to make some charts. He decided to do it like it was an Etch-a-Sketch. He didn't have any diagonals. So everything was along a line of right ascension or a line of declination. All the corners and intersections were, however, given according to the epoch of the precession of 1875. So in 100 years or more that have passed since then, the constellations are a little bit off because the pole has precessed somewhat. And you can see that in certain of these, like for instance, Scorpius here, minus 30 declination is used as the boundary. And you can see in a few places it deviates a little bit. You can see the lines sort of deviate. And the right ascension, they kind of deviate a little bit from the lines because the pole has moved a little. It's pretty simple. All he did was just what a surveyor does. He has a starting point and he had an ending point, which was the same as the ending point. He just sort of went around the boundary of the constellation, taking into consideration corners and places where the boundaries of other constellations. So he says, here's one between Lepus and Columba, and that had a point too. And then he went to the next corner and the next corner, et cetera. And so there's Canis Major. Somewhere a little bit more complicated, like I said, kind of like an Etch-a-Sketch, if you can see this. This is Serpens, which is probably one of the more complicated constellations because it has two parts. The middle few stars are being designated to Ophiuchus. But here's the survey for the head, the caput, and the tail, the cauda. Okay, and finally, what are constellations? And here's a view of Orion and Taurus from the Earth. Canis Major is just outside the field of view to the lower right. I'm sorry, the lower left. That's to the east. I'm sorry, to the west. And here's what it would look like from Alpha Centauri or Rigel Kent. Now, Alpha Centauri is about 4.3 light years away. But as I said, Aldebaran is only about 65 light years away. And Sirius in Canis Minor is about 8 light years away. So notice that even though Orion pretty much looks the same, all the stars being hundreds of light years away, Hyades and the Pleiades a couple hundred light years away, we now have a bright first magnitude star. In fact, it's -1 magnitude star next to first magnitude Betelgeuse, and that is Sirius. And Aldebaran has moved too. It's no longer part of a V. Spinning your scope around at your base on Alpha Centauri, Capella, first magnitude star in Auriga, is now kind of like moved from its original position. And the W of Cassiopeia is now, looks like Charlie Brown's shirt there because it's a zigzag, and there's a first magnitude star there. And that's because Alpha Centauri is on the opposite side of the sun from Cassiopeia. So Centaurus is one direction, Cassiopeia is the other direction. So this first magnitude star is actually the sun. Anyway, what are constellations? Constellations are the view that we have from Earth home. And it's a pretty nice view. Anyway, that's it.
Thank you, Bob. Are there any questions?
The first question is from Al Aho.
Okay.
Thank you for a very intriguing thought. I don't know why astronomy appeals to so many people and over such long periods of time, but I've always wondered, in the beginning, which came first, time or space in the Big Bang?
Well, there's one alternative. There's a third alternative, you know, and it's actually the correct one, at least as far as we know. And that is that they started simultaneously. We have 4 dimensions, three of linear dimensions, 3 of space and 1 of time.
But this implies that you have a definition of time.
Well, yeah, I think most folks find this kind of mind-boggling. So, you know, But the idea is that there was no before. It's because, time, I don't know, time in relative dimensions in space. The idea is that everything was, maybe a way to look at it is if you look at a black hole has in the center of it a singularity. And you may have heard, at least in relativity, the higher the gravity, the slower time proceeds. Higher velocity, time dilates. So you get, basically time moves more slowly at a higher speed, but it also moves more slowly at a really high gravity. So where gravity is really, really high, time slows down. And at a black hole, the singularity that's in the center of the black hole is actually a point. It has no volume, yet it has mass. Therefore, the density is infinite. So time does not exist, or it doesn't move anyway, in the black hole. So not only can you not escape from a black hole, once you get inside the Schwarzschild radius, time does not pass. So at least once you get to the singularity. So anyway, time and space, at least according to the Big Bang Theory, time and space began at the exact same moment. There was no before, there was only outside. That is, outside of reality, outside of what we would call reality, or actually material reality. So there may have been a, what is it? They say that God is transcendent. So there may have been a transcendent reality, but our reality of time, space did not exist. It was only a point that had all of the mass of the universe in that point. And then when the Big Bang occurred, it shot out, radially from there. Perhaps guided because it's not perfectly radial, but it is, that is, it didn't spread out perfectly radially. It coalesced in certain places, causing the galaxies to form. And the galaxies had points of coalescence in them that caused these other things to form. But anyway, I'm not sure if that's a satisfying answer or not. It's just that that's how they see it.
Well, the reason I asked this question is I haven't met a physicist who has given me a precise definition for the term time.
Okay. Well, I'm a
There's
geologist.
space-time, but not time.
Yes. Well, space-time is a sort of a grouping them together in Einstein's theory of relativity. He showed how they were interrelated, time and space, and all of these phenomena that we see. The astronaut who, the twin paradox, the astronaut who goes around the Earth and goes, a significant velocity, so that he's actually slowed down his own time scale. So he comes back, he's actually younger than his twin who remained on Earth, and things like that. Who was talking a little while ago about the why are we interested in nanoseconds? Well, they have these atomic clocks that they've put out, very, very precise clocks that go up in speeding jets or even spacecraft. And they're compared with identical clocks on Earth, and they show that they have lost some time in nanoseconds. But you have to be able to measure nanoseconds to measure that, I suppose. But anyway, pretty much the way we interpret things. In fact, Newton and Newtonian physics versus relativistic physics. See, there's a big change there. So Newton viewed things based on his own point of reference, his own viewpoint, his own experience. So he experienced physical things, and he was a brilliant mathematician and a brilliant physicist. There's none that surpassed Newton. But he looked at things from his own relative frame of reference. And I don't mean that in a relativistic sense. He, for instance, saw the movement of the planets. He looked at Kepler's laws and looked at the relationships between the planets and calculated certain things. But Mercury is really close to the sun, and it's somewhat, time passage is somewhat affected by its proximity to the gravity well of the sun. So Mercury didn't really match up at least perfectly with Newton's calculations for where it would be. I mean, he was able to plot where the other planets would be, but Mercury didn't exactly work out. But he said, well, instruments aren't really that great just yet. They're getting better, but our measurements aren't perfect. So he actually fudged. Newton fudged, and said, well, yeah, this one fits too, but it really didn't. So we got to go beyond our experience and look at these things on a cosmic scale in order to be able to see examples of some of these things. And like I said, black holes are a good example. But again, the gravity well of the sun having an effect on Mercury, that's a big deal. And so time is relative.
Thank you.
Thank you. Ron Weinger. Oh, Ron, here you have to unmute yourself.
Okay.
Ron,
Yeah, finally got to mute. Hitting the wrong buttons. Back ages and ages, like the last century, there was a company that was selling stars to you. You can buy a star and have it named after you. And was that anything that was recorded any place other than the book that was sold to you? Or was there any official recognition of any of that? Or was that just, you got a nice book, your name's in it?
Everyone that I know who talks about that, who has some experience in that area. I mean, first of all, it wasn't ages ago. I think a couple of weeks ago, I heard on the radio, you can buy a star, and the Star Registry and all this stuff. Yeah, there are stars out there. There's with photographic plates, etc. All these things are cataloged somewhere. You can actually go online and find a number of websites that actually have star charts for very, very tiny areas that fractions of a minute of arc or even of a second of arc of the sky. So they're all out there. They're not all cataloged. They're all known. They are mapped though, because we have these photographic mapping. And maybe with computers, they are actually all given a number. Usually they're cataloged by their position, which doesn't change much. But Star Registry and things like that, they're all, they may send something into the patent office, but I'm not sure whether or not, if you called the patent office and said, I'd like to have some information about my star, the one that I paid, whatever, $20 or $30, whatever they charge you for it. I don't know. I do know, though, people have come to the observatory and they have brought their certificate. You get a certificate when you buy these things. And it doesn't have the name of the star, but it says where it is. It'll give you the right ascension and the declination, or the latitude and the longitude in the celestial sphere. And no doubt there is a real star at that location. They've probably gotten it off of one of these photographic plates. But what they actually do with it, I don't know. I mean, as far as I know, they don't, they're honest about it enough so that they don't give you somebody else's card, some card that's been given to somebody else. But, people have come in and they want to see their star. And if we're not too busy, if there's not too many people in the public there, or if you want to have a special event to go look for your star, we can get you a point we can point a telescope in that direction and maybe even take a picture of it. And then you can maybe, from stars that we do have right ascensions and declinations, measure off which of the dots on that plate are your star. But it seems like a lot of trouble.
Bob, are you saying that the U.S. Patent Office is the official registry of star names?
Not that I know of, but that's what the ad said.
Oh.
I heard it on the radio. Star
Okay.
Registry. Look them up, Star Registry.
I mean,
see what they claim.
Oh, if there were such thing as an official name for a star, that would depend on there being some sort of a universally recognized Registry.
Okay.
So George Cull, you're next. I just sent you an unmute request there.
I got it. Two quick questions, Bob. Great talk. I really enjoyed it.
Thank you.
The first question, which I hope is very simple, is do you know of any videos for our grandchildren that would get them interested in astronomy? Let's say 10 and under.
There is a site at the University of Nebraska, Lincoln. If you type in UNL astronomy in your Google search or whatever, there is a site that is a astronomy education, and there is a plethora of teaching aids, videos, simulators, things that you can download to your phone that simulate various principles of astronomy. So that's UNL Astro, or astronomy maybe, and it's so just go to University of Nebraska Lincoln Astronomy Education, and they have a drop-down ribbon that has all kinds of aids. Not only that, you can use them if you don't make money off of it. You can use them without permission. They say over and over again, you know, if you want to use this for this, you want to use this for a talk, you want to use this for whatever in your classroom, you have permission. So, and they make no bones about it. They want it to be used. So that's where I would go.
Okay, great. Thank you. The other question I have, which might be a little more difficult, is you had mentioned that different cultures saw different images, again, due to their difference in culture. But did they usually pick the same stars to form the image? Nope.
Okay. No. There are Chinese constellations that use stars from 4 or 5 other constellations. In fact, there are some Arabic ones that asterisms that basically pick some nice stars from various other constellations, and from multiple constellations. So no, and you could do it yourself. R.H. Ray, who did the Curious George series, has a really neat book. If you have little kids, get R.H.A.'s book on astronomy, on the constellations. I forget what the actual title is, but it's the same guy who wrote Curious George. And he does some pretty funny things with the stars in that. But he also does have the actual constellations, but he connects the dots in funny ways. So that's a neat book.
Okay, great. Thank you.
You're welcome.
I'll slip in a very quick question here. Our earliest astronomers were apparently 17,000 years ago in the sky. So would the stars have noticeably moved, perceptibly moved since 17,000 years ago?
The closer ones would have. We have a thing called, what's it called? We have a thing called, well, I don't know, I forget what it's called. But anyway, the closer stars will move over time. And in fact, some of them are so close, like Barnard's star and 61 Cygni, move so fast that you can basically chart their position over, if you take a photograph of the sky over a couple of years, you will actually be able to see that the stars have moved. But that's only because they're very, very close.
Yeah.
So stars that are very far away, like the Pleiades, several hundred light years away, could easily have moved, from the positions that they're mapped on the ceiling at Lascaux in 17,000 years.
Okay, thank you. So I'm sorry, we still have a couple of hands up, but I think we need to draw it to a close. So
Well, I can answer quick.
all right, Griff, if you have a quick question, go for it.
He needs to be unmuted.
I know, he has to unmute himself.
I am.
There you go.
Okay, quick question. Do you have any interest in a really good photograph of the 1991 solar eclipse?
No. Not particularly.
Well, if you
sorry.
do, Griff, we'll send you one. He does photography of stars and
Oh,
moons
okay.
and
Yeah,
eclipses.
we have
He
a
does
really big
really
astrophotography
nice
group.
photography. It's worth saying
Right.
yes to that question. You'll get a great
Oh,
picture.
okay, then yes.
Okay. Hey, Martin, you're next.
Yeah, Bob, quick
If you'd
question.
like,
What's,
if you'd like to see it, I can send a digital file.
Yeah.
Oh, okay,
He'll
sure.
do that.
I'd like to,
Sure.
I'd like to see your photograph. Yeah.
Bob, a quick question. What's your confidence level that all the planets in our solar system are known? Is there something beyond Pluto? That's quick.
Well, the AIU pretty much closed the book on that. They basically said that the planets in the solar system are, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, and Uranus. And that's it.
That's a
everything else is
cop-out.
now a minor planet. And the reason they did that is because of people like you who asked that question. The reason is that they are constantly finding new planets, new smaller planets way out, beyond Pluto, beyond, the Kuiper belt. And they're finding lots of them. And the reason that they're only finding them now is that it's not actually easy to see them. Pluto was only found, by very careful observation of pairs of photographic plates. And they just, with a thing called a blink indicator, basically, they just flipped back and forth two pictures. They had this thing that would just have a mirror and it would show one picture, another picture taken several days apart. And occasionally one star would move. And that star was Pluto. And because it moved, it was a planet. The word planet means wander, planetos means wanderer in Greek. And so if it moved, it was a planet. So except for comets, they don't count. But the thing is that these things are hard to see. And so they're still finding them. They're way out there. There's a lot of space to look at, and they're finding them all the time. So the AIU basically said enough's enough, So we got to come up with something so that we don't have to do this, have to keep, adding on to the list of planets. And that's what they did. They erected a class called minor planets. And so if a planet was really small, or if an object wasn't small enough to even be a sphere, to draw itself into a sphere, if it didn't clear its orbit of planetesimals, and it wasn't already the moon of something else, then it was a minor planet. So yeah, that's it. That's all you get.
Okay, speaking of that's all we get, I think it's time.
All right.
So Jim, can you let me add a spotlight? There we go.
Okay.
Oh, Bob, can you unshare your screen at this point?
I'll do my best. How's that?
Perfect. Thank you. Okay.
Bob, thank you so much. The first way that we thank you is to present you with a certificate of appreciation, which you will get in the mail in due course. And you will notice on it that there's an orchid. And when the Old Guard was organized in 1930, Summit was one of the largest producers of orchid plants in the United States. The second way of thanking you is to give you an Old Guard salute where everybody claps.
Oh, well, thanks.